In this series, we're going to look at relations and then grow that further into the concept of functions. So if we look at relations, a relation is simply a way to represent the connection or a relationship between two elements. So I've got a set B here, 1, 2, 3, 4, 5, 6, 7, 8 are the elements of the set. Let's look at a relation R, and we look at the concept of less than. We all know what less than means. So if we look at the term less than, if I look at the set, then I know 1 is less than 2. So I can write 1 or 2. It's just a way of writing. That means 1 and 2 are connected with that relation. But 2 isn't less than 1. So we write it like that. But 1 is related to 4, 5 is related to 8, and many other relationships between the elements of those sets. So that's how we can write it, and the reason is because the relation is defined as less than, and we're looking at this set B. So if it's a relation, we can write it 1 or 4. So A or B, if A and B are the element set, what that means, if I know A or B, if I say A or B, I mean A or B is true. So if I know A or B, then I know that A is less than B for this example of a relation. So that's how we look at relations. So it's simply just a way to connect elements of a set. And all the elements of the set do not have to be connected with that relation. We've seen here that 1 are 2, but 2 or 1 is not. All right, so let's look at another one. Look at a set A, 1, 2, 3, 4, 5. Define the relation P on A by APB if and only if A plus B is less than 6. So that's a way to write it. That means APB is true if A plus B is less than 6. So there's quite a couple that'll work here. So let's look at, I've got 1P. Okay, 1 plus B must be less than 6. Well, I know 1 plus 1 is less than 6. 1 plus 2 is less than 6. 1 plus 3 is less than 6. 1 plus 4 is less than 6. 1 plus 5 is not less than 6. So that's not true. 1P5 is not true. And so we can look at all the elements. I can look at 2P1 is true, 2P2, 2P3, but that's where I stop. 2P4 is not, because 2 plus 4 is not less than 6, and so on. So I can form relationships between a lot of the elements in this set, and I can list all of them if I want to. So that brings us to our next concept. It's the next way to define a relation. If we want to make it more formal, we can define a relation as a set of ordered pairs. So R is the relation. The ordered pairs AB, they're in the set. The ordered pair AB is in the set if A or B is true. So let's look at the one we just had. If I have to look at them one at a time, R is then, well, 1 or 2, 1 or 1. Let's start at 1 or 1. 1 or 1 I know is true. Let's do this systematically. 1 or 2, 1 or 3, 1 or 4. And then I can look at 2. 2 or 1 is true. 2 or 2 is true. 2 or 3 is true, and that's why I stop with the 2's. 3 or 1, 3 or 2, not 3 or 3, 4 or 1, and not 4 or 2, and 5. 5 is not even there. So that's what I can look at R as an ordered pair, or I can write them as 1 or 1, 2 or 3, and so on. So this is different ways to look at it. So if I've got an ordered pair in R, that means 1 or 1 is true. So let's look at one more example that we're going to look at it like this. Define R on Z. So now I've got a big set. All the integers defined by A or B if and only if A minus B is greater than 10. So if I look at that, we're working on the integers. So there's going to be a lot of elements of that in that set. But let's look at a couple that we know is going to work. What about, so A or B, A minus B must be greater than 10. So 20 or 1, 20 minus 1 is greater than 10. 15 R3, 15 minus 3 is greater than 10. Let's play around with some negative numbers because we're working on Z. So negative numbers, what about that? What about 1r minus 5? Is 1 minus 5 greater than 10? 1 plus 5 is 6, so that's not true. But if I want a negative one there, 1r minus 10. 1 minus 10 is 1 plus 10, so that one's true. So that's how we play with these. Now, if I want to form the set R, if I want to write it as a set of ordered pairs, it gets a little bit more complicated because I don't have a limited number of elements. Z is infinite number of elements. But when we start off, we say R is all the ordered pairs AB, given A minus B is greater than 10. So that's how we can write it. Now, we're going to struggle to form a pattern or to make a list and list them all, but just remember that is how we can look at it. So a relation is just a way to connect elements of the set. Sometimes two of the elements of the set connect, sometimes they don't. And that is what a relation is. So we're going to look at some properties of relations in the next video.